Hello, my friends. I'm Clover, and this is Genuinely Approachable Sudoku, and today we are solving Column Like I See 'Em by Philip Newman. So the rules for this one are a little bit arcane. This is a 159 Sudoku. So in 159, you have three pink columns, the first, the fifth, and the ninth columns. And that tells you that digits in that column represent where the 1, 5, or 9 go in that row. So for example, if we look at column 1, if we were to put, say, a 4 here, that 4 in column 1 would be telling us where the 1 goes. So it's indexing the 1. So the 1 would be in the 4th position from the left, so we'd put a 1 there. Or over here, if we had like a 7 in that cell, that's in the 5th column, and it would be telling us that the 5 was in the 7th cell from the left, so the 5 would be right here. Or if same thing's true with 9, if this was an 8, that would be telling us the 9 was in the 8th cell from the left, so that would be right there. So let's have a look at this. So one thing, we also have standard Sudoku rules, of course. So we're placing the digits 1 through 9 once each in each row, each column, and outlined 3x3 region. And I got so excited I almost didn't mention the arrows. Digits along each arrow have to sum to the value that's in the circle attached to that arrow. Okay, that should be all of the rules at this point. Now, let's have a look. So one thing that's really useful to remember, not critically necessary in most 159 puzzles, but often useful, is that if you look at just the indexers in one box, there always has to be one cell here that indexes a 1 that's in the furthest away box, so there has to be a 7, 8, or 9. There has to be one that's indexing a 1 in the middle box, so there has to be a 4, 5, or 6. And then there has to be one that's indexing a 1 over here, so there has to be a 1, 2, or 3. And you don't know what order those go in, but combined with the arrows, that ends up being really useful. But let's start by looking at the digits we already have in the grid. So for example, this is a 1, and it's in the 9th position, so we have to have a 9 in the 1 column. And then we'll see what else we can fill in using that principle. So this is a 5, it's in the 4th position, so we're going to put a 4 in the 5 column. It's a 9 in the 4th position, so we're going to put a 4 in the 9 column. 1 in the 1st position, don't want to do anything about that, that's already in the right spot. 5 in the 6th position, 9 in the 6th position. Okay. Now we're going to look at this central column. So we have to have a big digit here, so this has to be 7, 8, or 9, and it can't be 9 because there's a 9 in the region already. So this is 7 or 8 equals 6 plus 1 or 2. And up here we have to have a big digit. It's got to be 7, 8, or 9, can't be 9 because there is already a 9 in the region. But it also, in this case, can't be 8, because if it was 8, we'd be summing two 4s together. So this has to be a 7. And that tells us that the 5 here is in the 7th position. And furthermore, 7 is 4 plus 3, so the 5 here is in the 3rd position. Now we've used the 7, so this can't be a 7, it must be an 8. So now the 5 down here is in the 8th position, and the 5 here is in the 2nd position. Now, our remaining digits in this region are 1, 2, 6, and 8, and we can't have a 1 there, and we can't have a 6 there. And our remaining digits in this region are 1, 3, 4, and 7, and we can't have a 1 there, and we can't have a 4 there. So let's carry on. So if we look at this arrow, we have to be adding something to 6. So we have to be adding a relatively low number, either 2 or 3. We can't use a 1 because there's already a 1 in the column. Well, 6 plus 2 is 8, which would give us 2 8s in this row. So it must be 6 plus 3 equaling 9. This doesn't tell us anything new here because we already know now that the 9 is in the 9th position. But here with the 3, 9 is now in the 3rd position in this row. So we can place a 9 right there. Now we need some more digits in this column. Normally I wouldn't pencil mark when I had this little going on, but hopefully this will reveal something. So these need to be 2, 5, 7, and 8. So the sum here has to be 7 or 8. And then the summands can't be 8, can't be 7, those are too big. So this has got to be 2 plus 5, that's going to be a 7 now. That makes this digit an 8. So we can place a 9 in the 7th position here, we can place a 9 in the 8th position here. And that's not an 8. We're going to have a 9 in the second position in one of these rows. It can't be this one because there's already a 6 there, so it's right there. That's a 2 and that's a 5, placing a 9 in the 5th position. So the last 2 digits in column 5 are 1 and 5. Now these digits are going to be 1, 3, 6, and 8, and we can't have a 6 there because there is a 6 in that row already. These are going to be 2, 3, 7, and 6, and we can't have a 3 there because there's already a 3 in that row. And that's not going to be a 7. So now let's focus on the first column. So we have 5s here and here, so there has to be a 5 in one of these cells. And then this is going to be a 7 or an 8. So this is going to be either a 2 plus 5 or a 3 plus 5. This is also going to have either a 2 or 3 because it has to have a low digit. So it's either going to be 2 plus 7 or 3 plus 6. And let's see if we can make some eliminations there. So this can't be a 3. So this can't be a 3 plus a 6. Now we actually have a 2, 6, 7 triple. I didn't use this when I first solved this puzzle, but I'm going to use it now to eliminate 2 and 6 from this cell and make this either a 1 or an 8. So 1 is in position 2, 6, or 7. It's not in position 7, so that's not a 7, meaning that's not a 2. And now 1 here is in position 3 or 7. It's not in position 7. So that's going to be a 3 and a 6. So we can eliminate 6 from here. That's not 2 or 7, that's not 2 or 7. That means we've used our 3, so this is going to be 2 plus 5 equals 7, and my last 2 digits here are 4 and 8. Now, I've placed a 7, that tells me 1 is in the 7th position. I have a 2 there now, so that's a 5 and a 2, and a 1 and a 5 there. These 3 digits must be 1, 3, and 8 to finish off this row. And these are going to be from 1, 3, 4, and 8. That can't be a 4, so that's the only position left for a 4 in this region. We can eliminate 1 here, meaning that this is the only position for 2 in its row. And that gives us an 8 there, which resolves a few things. That can no longer be an 8. This has got to be 3, 7, or 8. That's got to be 3, 7, or 8, and there's an 8 in its column already, so it is not an 8. We have a 3 right here, which makes this a 6. And then the 3 resolves the rest of this region, which in turn resolves the rest of this region. The 8 in row 4 gives us a 3 there, and finishes this. These have to be 1, 2, and 7, and that can't be a 2 because there is a 2 in the row. These guys have to be 2 and 4 to finish off their row. These are going to be 1 and 7. Those are going to be 2 and 3. These are going to be 6 and 7 to finish the region. I can resolve this 3, 4 now, which resolves this 1, 7. My last digit in this row is now a 2, which resolves this. And here I need a 4 and an 8. And my last move is going to be to use the 1, 5, 9 constraint one more time. 1 is in the 8th position, so this is an 8, not a 4. And that's how you solve Philip Newman's column like I see him. Hope you guys liked that one. The link to check it out yourself is in the description of this video, and I will see you again in 3 days.